Hi everyone, welcome back to this last section of optics. Again, we're doing thin lenses, but a little bit of harder problems this time. So a magnifying glass, a converging lens, forms a real image that is 3 times larger than the object. If the image appears 24 centimeters from the lens, what is the focal length of the lens? Alright, so a few things here. If the image appears 24 centimeters from the lens, distance of image, 24 centimeters. Real image that is 3 times larger. Magnification equals 3. I think that's all the information that we have. Okay. That being said, though, we can find out a few other things. So we know magnification is equal to negative distance of image divided by distance of object. So we know that this is equal to 3. We know the distance of image is equal to 24. And then the distance of object is something that we can find. Okay. And if we have this distance of object here, 24 divided by 3, we can do that the distance of object is 8 centimeters. Okay? Great. So now that we found the distance of object, this should be able to help us with a few things. We should know that 1 over the focal length, and that is what we're looking for, right? The focal length is equal to 1 over distance of object plus 1 over distance of image. So to find the focal length, we just have to find the inverse of this. 1 over distance of object, which is 8, plus 1 over distance of image, which is 24. Inverse of that, and let's figure this out. 1 divided by 8 plus 1 divided by 24. Inverse 6. So the focal length is 6 centimeters. Alright, moving on. Alright guys, this problem is quite a bit harder on example number 12, also the last example we're doing here, but let's see how much you guys can do. Alright, so you're setting up a projector in a classroom. The projected lens has a focal length of 25 centimeters, and you want to display an image that is 3 times larger than the original slide. Focal length, 25 centimeters. If the slide is placed directly in front of the lens, how far from the screen should you place the lens in order to project the image onto it? Okay, so I guess this would be like the screen, and we want to know how far the lens is from here. So the distance of image. And then from here to here, what I guess would be the distance of object from this lens. Okay, so a few things we know that since this is getting projected onto a screen, this is a real image, and only a converging lens can make a real image. So this is converging. And let's see what else we know. We know focal length is equal to 25 centimeters. We know magnification is equal to 3. But what we should know is if it is a real image and it is converging, that means that it is going to be inverted. So this should be negative 3. Okay. So just to make that more sense, it's going to be like this. And then it needs, since it's on the opposite side, it needs to look something like that. Okay, so that's why we know it's negative. That being the case, we should also know, okay, we're looking for a distance image. That being the case, we should also know that magnification is equal to negative distance image divided by distance object. This is negative 3. So this is going to be equal to distance. We don't know what distance image or distance of object is, but we know that distance of image has to be 3 times the distance of object. Okay, so 3 times distance of object equals distance of image. That is something we should know in order for the magnification to be 3 times as much. Alright, so using that, let's see what we could find out. 1 over the focal length is equal to 1 divided by distance of object plus 1 over distance of image. So we have 1 over 25 is equal to 1 over distance of object, which is, we're just going to put distance of object. Let me erase some of this stuff. 1 over distance of object plus 1 over distance of image, but we're just going to do 3 distance of object. Great. So let's just simplify some things. 1 over 25 is equal to 4 divided by 3 distance of object. Hopefully you guys can do that. And we'll just cross multiply a little bit. 3 distance of object is equal to 100 divided by 3. And we should say distance of object is going to be equal to around 33.33 centimeters. So great. We found this. But we still need to find the distance of image. But we know that distance of object is equal, 3 distance of object is equal to distance of image. So 3 times 33.33 is equal to 100 centimeters. And that's what the distance of the image is going to be, 100 centimeters. Whew, that one was pretty challenging, pretty tough. A lot of little things that are pretty tricky. If you're able to get that, great. But if you had a hard time, highly suggest watching that again. Thanks for watching, everyone.